Unit 7, Day 7. The objectives are helpful here to see what's going on. We're going to use a calculator and understand that calculators use trig inverses. So they will not give answers for some quadrants. So it only gives the answers for the quadrants that are defined by the inverse function. And then we'll use a calculator to do word problems. So first of all, notice that our calculator has to be in radian mode. And so if I go to mode and go down to the line that says radians and degrees, right now degrees are highlighted. If I press enter on radians, now radians are highlighted. It also says that I want to round to 3 decimal places. Where? Well, our calculator will do that. If I go up to float, float means it'll put the decimal where it thinks it should go best. But if we know better, we can go over to 1, 2, 3, 3 decimal places and press enter. But remember, you've done this. Now everything is 3 decimal places. If you want to go back to float later, you can. So we're going to use our calculator to find the angle in the first quadrant where sine is positive. Well, sine is positive here and negative here. In terms of the inverse functions, remember, from negative pi over 2 to pi over 2. So if I do second and sine and 0.23 and press enter, we have 0.32, and notice the calculator rounds to the nearest 3 places. So we can say approximately 2.32. And that must be this angle, 0.232. But I'm solving this statement. I want all theta that work. So sine is also positive in the second quadrant. This reference angle is about 0.232. This reference angle is about 0.232. So to get this rotation angle here, what I can do is I can do pi, or 180, and back up. And this, since I'm doing radians, it has to be pi. So the other quadrant is going to be in the second quadrant. And to solve that other angle, we're going to do pi minus 0.232. Here's what we can do. We can do second pi and then subtract. And if you notice, 0.232 is the most recent answer. So I can do second, and down here at the negative sign above it is A and S, most recent answer. And if I press enter, it won't only just subtract the 0.232, it'll actually subtract all of the decimal numbers that are part of that, and then round after that. And so our rounded answer is about 2.910. So the general solution is going to be that first answer, which is 0.232, and then plus, since we're doing radians, 2 pi around and around and around k, and of course k is an element of the set of integers. And then this other angle that we have in the second quadrant, 2,910, and then round and round and round, all angles that land in the second quadrant, they're all coterminal. Remember that word? K is an element of the set of all integers. So here's what we just did. Let's say we have this angle theta, and it's in the first quadrant, let's say. Now if I go pi and back up that same angle theta, look at, I have the same y and the same r. Isn't sine y over r? So that theta and pi minus theta give us the same sine value in the first and second quadrants. Now cosine, let's say we do this for theta here. And so theta is positive in the first quadrant, but isn't it also positive in the fourth quadrant? That's when x is positive. So here is the same x value, the same x and the same r. Isn't this angle, this angle, 2 pi, and then you back up that reference angle. So that gives us the same x and r in the first and fourth quadrants. And then for tangent, tangent's positive in the first quadrant. Let's say we have this is our theta. And tangent's also positive in the third quadrant. Same reference angle right there. Isn't that pi plus that reference angle? Pi plus theta, where this is theta in the first quadrant. You don't necessarily have to remember these if you can just draw these pictures and remember which quadrants have the same value. So same thing we did a moment ago. Let's say that theta is here. Notice this is positive and this is 0.3. Cosine is also positive in the fourth quadrant, right? So the reference angle here is 0.3. It's negative, I know. But to find the other angle, don't I go 2 pi and then back up that same 0.0 or 0.3. So let's do that on our calculator. So second cosine of 0.3, we're looking for the angle that has that cosine value. So 0.3 is the cosine value. If I press enter, I get the angle in radians that has that cosine value. So that theta in the first quadrant is about 1.266. The one in the fourth quadrant is again 2 pi minus that angle we just found, which is 1.266. So I can go 2 second pi and then subtract. Well, 1.266 is the answer I just found. Let's do second answer and enter. And this other angle is actually about 5.017. That's the angle. They have the same cosine value. So this angle up here was 1.266. That's the angle. That's the angle. They have the same cosine value. So with these directions between 0 and 2 pi, here is the first quadrant angle, and here is the fourth quadrant angle. Remember, 2 times pi, that's 2 times 3.14 or so. That's 6 something. Aren't these both below 6 something? Makes sense. For our general solution, we can go 1.266 and then around and around and around plus 2 pi k and 5.017 plus around and around and around 2 pi k. In both cases, k is an element of the set of integers.